So the next question is question number 13, and the question is say a spherical soap bubble inside the air chamber at the pressure P naught equal to 10 to the power 5 of Pascal has a certain radius so that the excess pressure inside the bubble is 144 of Pascal. Now the chamber pressure is reduced to 8 P naught by 27 so that the bubble radius and its excess pressure is going to be changed. In this process, all the temperature remain unchanged. Assume air to be an ideal gas and excess pressure delta P in the both cases to be much smaller than the chamber pressure. The new excess pressure delta P in Pascal we have to be calculate. So question is say there is a chamber like this, and inside this chamber there is a air bubble. Just made this thing like this, and there is a air bubble inside this chamber. Okay, so the pressure of this chamber, that is P naught, equal to 10 to the power 5 of Pascal, and the excess pressure inside this air bubble, that is 144 of Pascal. Okay. Now the thing is that the chamber pressure is going to be reduced, and it is be like 8 times of P naught by 27. And for this, the air bubble inside pressure, that is excess pressure, delta P 2, that we have to be calculate. Okay. So that is with the question. Now we are going to approach this question, and one thing is that the temperatures remain unchanged. Means this process is going to be an isothermal process. For this, temperature is going to be constant. For that case, we can take the volume into pressure as a constant. Okay. So now we are going to approach this question. We are taking the thing that is pressure into volume that is constant. Okay. For this, the first chamber, the absolute pressure will be like that is P1, and that will be P naught plus delta of P1. And for this, the absolute pressure, that is again 8 times of P naught by 27 plus delta of P2. Okay, so we know this. For an isothermal process, we can take the pressure into volume as a constant. So we are going to approach this question by this method. So basically, we can take pressure into volume as a constant. So the P1 V1 equal to P2 V2. We can put like P1 V1 equal to P2 V2. Okay, so the P1 we can write like this and continue this question by the same method. So P1 is be like P naught plus delta P1, and the volume is 4 by 3 pi R1 cube, and that will be equal to 8 times of P naught. Let's solve this question. That is 8 times of P naught by 27 plus delta P2. Okay. That will be multiplied by 4 by 3 pi R2, and that is whole cube. So the 4 by 3 pi to 4 by 3 pi, that will be cut out. And the next thing is going to be like, just solve this question continuously. Next, we can write this radius. Okay, so the radius for this condition in this excess pressure, we can write that will be equal to 4T by excess pressure. Okay, so that thing that we have to be understand, and we are going to apply this. So P naught plus delta times of P1, and this radius can be written simply. So we can write this, that is 4T by delta P, delta P1, and that is with the whole cube. Next, similar for this, that is 8 P naught by 27 plus delta of P2, and that will be like R2, and that is whole cube. So that is PT 40 divided by delta of P2. I am writing like this, and we are taking the whole cube of this like this. And you can take the complete bracket for this also. Okay. It is like this. Now solve this equation continuously. So 40 to 40, that is going to be cut out, and the result will be written like P naught plus delta P1 divided by, that is delta of P1 to the whole cube, and that will be equal to 8 times of P naught by 27 plus delta of P2. Okay, and that will be completely divided by, that is 1 by delta of P2 to the whole cube, like this. Okay, so we are going to approach this question continuously. There is a one thing that is given to us, the excess pressure inside the air bubble, that is much smaller than as compared to the chamber pressure. So basically in this process, we can ignore these quantities. Okay, so we are taking these quantities as a negligible. For that, we can eliminate this thing. So finally, we can write this equation like, that is P naught by delta of P1 to the whole cube equal to 8 times of P naught by 27 into, that is 1 upon delta P2 to the whole cube. Okay, so you can take completely as a whole cube. Now just solve this equation, the P naught to P naught, that is going to be cut out, and we have to calculate this delta P naught to value. So that will be like the whole cube form equal to 8 by 27 into delta of P1 to the whole cube, like this. Okay, so we can write this equation. I am writing like here, and that is be like delta of P2 to the whole cube equal to 2 by 3 and delta of P1 to the whole cube. Clearly we can see that delta of P2, that will be equal to 2 by 3 times of delta of P1. So we can continuously solve this equation. So that is 2 by 3, and delta of P1 we have given, that is 144. So just put this value, and that will be like 4 into, that is 8. So the correct answer will be like 96 of Pascal. So that is with the excess pressure in the air bubble second. Okay. So thank you very much to watch this video.